Alright guys, this video is part 3 of U7L2 graphing rational functions. Sorry guys, I'm just getting my music going. I know you guys love this music. So yeah, basically we're going to look at a little bit different types of rational function graphs. Okay, real quick, just show you some different things that can happen, and that's it. So we've got this example 3, right? Basically, if you look at this graph has no vertical asymptote. Okay, we've got this behavior like this. We have a horizontal asymptote, but there's no vertical. Okay, why is that? Well, if we look right here, I'm gonna zoom in a little bit. If we look right here at our denominator, 2x squared plus 1 can never equal 0. So we do not have a vertical asymptote. Everything else is still the same. Okay, the horizontal asymptote we find the same way. We look at the degree here. The horizontal asymptote is going to be -2. We want to get a couple points. So an easy point is to find the y-intercept, right? That's 0, 1. You can figure out why that is if you pause the video and do that. So we've got this point. And then for the x-intercepts, right, I wrote that we always set the numerator equal to 0 to find x-intercepts, right? If we set the numerator equal to 0, we get that 1 minus 4x squared. That's a little bit of a reverse way to think about it, but that factors as 1 minus 2x, 1 plus 2x. And so we get plus or minus a half as our x-intercept. So we have these 3 points, right? These 2 x-intercepts, this y-intercept. We have 1 horizontal asymptote, okay? That's it. So the graph has to look like this. It's going to go up, it's going to touch that y-intercept, it's going to come right back down and approach the horizontal asymptote. Okay, easy domain. The domain's all real numbers. There's no vertical asymptotes. And yeah, we can see that the range is y greater than or equal to 2, right? That horizontal asymptote in this case never gets crossed. Just if you want to check that, remember you always can do that. You can set your horizontal asymptote equal to your original equation. So that's -4x squared plus 1 over 2x squared plus 1. Okay, I'm going to move this over to the left side by multiplying both sides by that. And then we get -4x squared minus 2 is equal to the original numerator on the right side. Okay, this can't happen. The 4x cancel, 4x squareds cancel, excuse me. -2 is never equal to 1. So yeah, there's no place where y is equal to -2. Okay, so that's an easy way to check if you have the time. Does the horizontal asymptote get crossed? So this is a big check. Done with that one. All right, case 2, right? This is a hard one because in this case there is no horizontal asymptote. Okay, so what really happens, and what you can look at or you study next year if you take calc, is you get a slant asymptote. So you get a line that forms the asymptote. And I haven't drawn this too well. Really, this graph is going to go up and it's going to approach this line, okay? But we have to do long division to get that line. That's beyond really what we want to do in this course. So you don't have to really worry about that, okay? If we go through the same process, we have a vertical asymptote. Remember, that's going to be the value that makes the denominator equal to 0. That's right here. Again, that value does not make the numerator equal to 0. It makes the denominator only, so that's our horizontal asymptote. Like I said earlier, there is no horizontal asymptote. Why? Well, because in this case, the degree of the top is bigger than the degree of the bottom, okay? And so there's no numerical limit that the expression approaches as x goes to infinity, okay? We go through our processes, we find these x and y intercepts, right? This one's a little bit weird because we can't get an exact value without a calculator. The way I did it is I said that, okay, well, the x-intercept is going to be plus or minus 25 over 2, right? That's looking at that numerator. 25 over 2 is about 12.5, or it is 12.5. And 12.5, when we square root it, is going to be between 3 and 4, right? Because 12.5 is between 9 and 16, okay? So that's good enough for us to get a rough graph. So I plotted, like, it's a number between 3 and 4, but negative here, positive here, okay? And I did a couple other test points. I picked x equals 1. That's an easy value to test left of the horizontal or the vertical asymptote. I picked 5. That's an easy value to test. And I got 2.3 as my value when x is 1. I'm just kind of realizing now that should be up here, shouldn't it, guys? Here's 1, here's 2. Let me change that. Yeah, that's not good. Can't plot 2.3, so it's really up there, okay? And it, it just changes the shape of the graph. Well, not really the shape, but just the y values slightly. Okay. When x is 5, I got 25 over 30, which is a little bit less than 1, right? And so that's the shape that we have here. Graph goes through these 2 points, has to approach the vertical asymptote, and just continues to go up forever. Okay, so our range is all real numbers because we have, the graph decreasing forever here, increasing forever here. There's no gap in between the middle section, so y can be anything. The domain is all real numbers except 2, right? We have to exclude any vertical asymptotes from the domain because they never get crossed because they are literally domain restrictions. So case 2, a little bit weird. You have this, no horizontal asymptote scenario. Okay, last case, and this is a quick one. I'm gonna start with the conclusion right here. Right, basically, if you have a scenario where you have a factor in the denominator and it's raised to an even power, such as x plus 3 squared, well, what really is going to happen there is at the x value that makes the denominator 0, which in this case is -3, right, rather than the graph do something like this, right, where it has this opposite end behavior, or excuse me, opposite behavior of the asymptote, it's going to approach the asymptote from the same direction. So if you notice here, right, from both directions, we're going to positive infinity. Okay? That doesn't happen here. And this one. It doesn't happen here. Right? It only happens, right, because look, here we had 2 separate factors. They're each raised to the first power. Here we had 1 factor, it's raised to the first power. Okay? In this case, when you have a factor in the denominator raised to an even power, right, you're going to have the same behavior at the vertical asymptote. Okay, so if we go through this really quickly, vertical asymptote is -3, horizontal asymptote is 0 because the degree of the bottom is bigger. Easy point, no x-intercepts, nowhere where this equals 0. Okay, so really if we have this y-intercept, and that's enough to guide this whole part of the graph, right? Because we approach both asymptotes. We can't cross this asymptote. We can't cross this asymptote. The one other value that I found, or the point that I checked or got, was -4. I just picked an x value to the left of my vertical asymptote, plugged in. When we plug in -4 here, we get 2. Okay, so this point is enough to guide this part of the graph. The graph has to approach this horizontal asymptote. It has to approach this vertical asymptote. Again, does not cross this horizontal asymptote because that's y equals 0, and this function, because we have a 2 in the top, can never equal 0. So I think that's enough. That helps with our domain. It helps with our range, and that's it, guys. So this is actually the second time I made this video. I have no idea what happened the first time, but I'm hoping this time it will go through. All right, so I'm gonna end the video, and I'll see you guys on the next one.